Good evening, everybody. I hope I can be heard. If I can be heard, a thumbs up so I know I can be heard by everybody.
We can hear you, sir.
Okay. All right. So today we are going to continue. Um, we are going to continue our section from where we ended on DCIT 201 programming 1. Okay. So first of all, let's go back and have a little bit of recap. Okay. Today there are so many things that came into mind. One of those things is trying to help with the setting up of the IDE before the lecture starts to go to that field. Because looking at the nature of the lecture we are having, I'm very, very sure that with he telling us how to download these IDEs and things, he's not really going to waste time with now install this, now install this, now. He's just going to tell us that go and download this, and install. By the way and manner in which it should be done, I'm not sure he will take us through. Because looking at the way he says he's going to combine three programming languages at a go there. So you can, I don't know if I should use some of the time given to me to do that. Or you can DM me in your personal time, your personal hours to also receive assistance. But I will not deny the fact that I'm very, very busy. Okay, I'm a very, very busy person. So if I don't reply to your messages that instant, okay, it's not like as if I've ignored you. I will attend to your messages. Okay, so either ways, I'll probably get into the end of this class. We'll know what to do. Okay, so that is that. Let me share my screen so that we start. Okay, so we are going to go into PowerPoint presentation. Okay, so let's look at what we we looked at last week. Are you okay? Let me minimize it a little. Okay, so we are going to have a quick throwback. Okay, so we talked about objects oriented programming or development. Okay, and we saw the section outline. We said at the end of the day we should know what an object and an object class is. We should know what an object oriented design process is, but we are not able to look at the unified modeling language. Okay, and we are going to do that today. So you take note of that. Now we also looked at object-oriented development, and we said that it goes in three folds. Okay, so we have object-oriented analysis, object-oriented design, and object-oriented programming. Okay, even though they are all related in some way, they have their distinct attributes. So object-oriented analysis is concerned with developing an object model of the applications domain. Okay, so I explained that the last time what object-oriented analysis is. And I don't know if anybody has a question about this one before we go on. If no question, we can go on. Okay, so we also have the object-oriented design, which is also concerned with developing an object-oriented system model to implement requirements. And then the object-oriented programming is also concerned with realizing an object-oriented design using an OOP, that is the object-oriented programming language, such as what Java and things. So the object-oriented programming has to deal specifically with writing the code. Okay, so that is that. So we take note that OOE is the first step when building a software, okay, using object-oriented ideas. So the goal is to study the problem and figure out what real world what real world things like objects the system needs. So for analysis, we know what analysis to analyze something. So first of all, you have to look at the problem involved. Then you look at what real world objects, okay, or things can help create that system needed to solve that. That's what we mean by the modeling. Okay, you don't need to write code at this point. Okay, you just analyze and plan. That is what you do at this point. Okay, so for example, let's take a daily example. Imagine you are designing a library system. Okay, imagine you are designing a library system. So objects you would identify as some books, members, and some librarians. Okay, so these are the objects that you need to put inside the library system for these because these are the things that are actually going to solve the problem at the end. If I create a library and I don't have books in it, what is this then? It's just a building. Are you okay? So if I create a library, then I don't put librarians inside, who's going to work there? Are you okay? If I don't also um put inside the members who are going to use the library, then what use is it? So this is identifying the problem and looking at the objects or the things that are needed to be able to implement a system that can solve that problem. As I said, not to solve the problem, we are creating a system. The system is made up of the objects. Okay, so which objects are needed for a library system? Okay, we need books, we need librarians, we need members. This is object-oriented analysis. We are analyzing the problem. Are you okay? Please, I hope at this point, like that understanding has been made. Let me come back to my Teams interface so I can see if anybody has a hand up. Okay, nobody has a hand up at the moment. So it means that understanding has cut across everybody, right? Okay, then let's continue. Then we come to I'm just brushing over this. Okay, we come to the OOD. Okay, OOD, and from what is presented here, design. Okay, this is concerned with developing an object-oriented system model to implement the requirements. Okay, so first of all, we looked at the requirements. What is required to create that system, okay, to solve that problem? The requirements of creating, if I say the problem is you don't have a library, as I stated earlier, the object-oriented analysis is okay, I'm creating a library, but what are the objects I will need to make up that system called library to solve the problem of I don't have a library or we don't have a library? I hope you are getting what I'm trying to say. But the object-oriented design, okay, has to deal with the system model to implement these requirements. So how will I implement the requirement? First of all, what did we say the requirements are? We said books, we said members, we said librarians. Are you okay? So how do I implement these requirements? This is the object-oriented design. Okay. Okay, so after you analyze the problem in OOA, okay, the object-oriented design is the step where you design the solution. So you design the solution using the objects that you required of from the object-oriented analysis. Are you okay? Yeah, you decide how these objects will work together in actual systems. So how would librarians work together with the books, and how would this also work together in serving the members? Do you understand? In doing this, you are designing to solve that problem. You are creating a design of how these objects will work together to solve the problem. And I don't think I have to waste time on object-oriented programming, since I said that this is when you actually code. This is where the coding comes in. Are you okay? So imagine you are building a library again. As I said earlier, object-oriented analysis, you identified objects like books, members, and librarians. The design is you now decide how a book object stores its title and artist. Okay, how a member how a member object keeps track of borrowed books. Okay, how do you keep track of that? If, the fact that a member came to borrow a book or read this book today, all these things. Okay, we are looking at how, when we come to object-oriented design, how is the most of the question asks, how does this work with this? How is this going to work with this? How that will help you design it. Are you okay? Good. Then we also ask a question like how a librarian object, okay, issues book. So how does the librarian tells you that this is the book where this is where you find it. This is so all these things goes into the design when it comes to the design aspect. I hope everything is clear. So if not, you have question you can raise. If not, to like some kind of reactions from about 2, 3 people, so I know that I can proceed. Understanding has been achieved totally. Okay, Joshua, thank you. Let's continue then. So on that note, we looked at what objects are, and I said objects are entities in a software system which represents instances of real-world end system entities. Object classes are templates of objects. I'm going to explain all these things all over again so that you get a concept. They may be used to create objects. Um, Object classes may inherit attributes and services from other object classes. So take a class. First of all, let's look at what a class is. Take a class to be like a recipe for preparing the food. Okay. At the end of the day, what comes out after following that recipe is the object. Are you following? And the food based on its recipe, what came out, the object that came out of the preparation of the food, which is the object, where the recipe became the class. Okay, that object is going to hold some attributes that is going to be as a result of the recipe you followed. Maybe it's supposed to be sweet, not salty. Are you okay? That attribute it holds makes it eligible to exist inside that class. Do you understand what I'm saying? So, as I said earlier from our previous meeting, I said that objects hold attributes. They hold attributes. Do you understand? And it's either they are inheriting that attribute or they are giving out. As I said, to inherit something comes in 2 ways. Okay, if I say I'm inheriting something, it's either it was given to me. Okay, it was given to me, or let me say um either I took it by working for it or it was given to me. And I think the last time we explained how these things come across cuts across. Okay. So it's either the parent class gives it to me or I take it from there. Do you understand? This is that simple. So if at a certain point, following a particular recipe, which is a class to create an object, which is the food that comes out of the recipe, another thing also followed that same recipe, but getting to the end, okay, something changed, bringing out a different object. At a certain point, it has some kind of inheritance from another class. Do you understand what I'm trying to say? Okay, so that is all I'm just trying to say with objects and classes. Are you okay? Then we come to um I think with the as to overcome the problem, scientists, this one is nothing too much that you can't. If you read it, I think you understand. Better even as just throws more light on what I've explained. Okay, it's nothing. And I think I've even talked about what a class is. I think I have to minimize this thing little so everything fits on the screen. Okay, I've spoken about what a class is, and I said a class describes a set of objects with the same behavior. Are you okay? So, as I said, take a class like a recipe, okay, for preparing a food or a particular something. When you follow that recipe, what comes out of it is the object. Are you okay? So what I'm saying that they are sets of they describe the object. There is one way or the other. The recipe tells you what kind of um objects will come out of it. You know what kind of food will come out of it. Are you okay? Good. So if I follow the recipe to prepare the same kind of food over and over again, those same food will have something in common. Okay. If pancakes, all those things there will be pancakes because I follow the recipe for pancakes. Do you understand? So they have the same behavior because they are belonging to the same class or they followed the same recipe. If I'm using that kind of example, do you understand? Yes. So when I also talked about the set of all members methods, and we'll look at what a method is. A method is like an instruction that directs an object to do something. Okay, so the set of all methods provided by a class together with the description of their behavior is called the public inheritance of the class. The public inheritance of that class. The public inheritance of the class. Okay, so we take note of that, which I will ask probably at the end of the session. I'll say that the set of all metals, that is what tells the objects, what tells the pancake what it is used for. Are you okay? And the set of all metals, sorry, provided by a class, okay, together with the description of their behavior is called the public inheritance of that class. Are you okay? So I will ask that question at the probably at the end of this section if I don't forget. They've also talked about abstraction and encapsulation. And I said I tried to use like the C out to explain. Then I said that when it comes to abstraction with regards to C out, okay, abstraction is providing you some amount of information about the function of that C out. Okay, so we know that when I type C out, at the end of the day, I'm going to print out something to the console. That is the information provided to you. But ideally, how it works, let me say how the C out is executed, you don't know it. Please, do we all understand? The information, a basic information you need to know about how it functions, you know, but how deep into the how it functions, you don't actually know. That is what we mean by what abstraction. Okay, so refers to using simplified classes rather than complex implementations of code to access an object. So instead of typing the whole complex code to actually bring out how the object should behave or to have access to the object, rather give you a basic what or a simplified way of telling you that C out prints out something to the console. Do you understand? But we don't tell you into details how C out does the printing. Do you understand? And then the this one, the encapsulations also said that. Good. Let's take Coca-Cola. As I was trying to use Coca-Cola to explain, or even if I still stick to my same C out, I'm trying to say that what came about building that C out has been kept from you. Understand that. How the C out was built. If I say sit in a car and drive, what do you need? Do you need the paddles and then the wheels? Okay. And then we know that we turn left, we know that we turn right, we turn this, but and we also know that you have to press on the accelerator and that to be able to move brake, and we know this basic information, but how the engines is burning the fuel, you don't know. They have not opened the engine to see how the fuel combustion is going, how the parts are moving, which one goes first, and then that is abstraction. You are giving the basic information you need to move your car, but how the engines are working and how the parts are working together, you don't know. Now encapsulation is how the engine was built, has been totally taken away. If you pick the manual of a car, they will not tell you how the engine was built. That is, they trying to give you one way or the other a chance to go and create your own engine. Then what is the purpose of buying this? Because if I am telling you how it was made, it means go and make some your own. So encapsulation, and taking Coca-Cola again as the example, I was saying that the ingredients were placed on the bottle, but how the ingredients, which one came before which temperature was given to one and which one, in fact, how the preparation process went on has been encapsulated. It has been kept from you. Please, I hope that the difference between abstraction and encapsulation has been made, like the understanding of it has been made. If so, please, like a thumbs up or something as well. So I know that the understanding has been achieved. Or a question, anything. Yeah. Joshua, your reaction there. It means if you enjoy Joshua,
Yeah,
Yeah,
it's, my
can
problem
go
is
back.
that
come again.
my problem is that you see the abstraction you use CR to do the example,
Yes,
but when you
please.
reach there you use Coca-Cola, so you are not trying, you are not getting this thing. So maybe
Okay,
if you
so
can use
I will
Coca-Cola,
use the same C out. I'll use the
yeah.
same C out. As I said for C out for abstraction, I said that the basic information about how C out works has been provided for you. And what do you know about C out? The thing the code you write C out. What do you know about it? I just want you to answer that for me. What when I tell you that type C out, like its basic function, what do you know that it does?
Print out.
Very good. It prints out something to the console. But do you know how the printing out is done? Do you know how the C out works in the machine before it prints out something to the console? No, right? Or maybe you do. Do you?
No.
So all we know is that the basic information provided with that when I type C out, the end result is that something must be printed to the console. But how that is done, I don't know. Do you understand the abstraction?
Yeah.
Okay. Now, encapsulation with that same C out is the code that was placed together, because you know that the C out is like it's like what do you call it? A mnemonic or something to like represent the actual codes that went about to build that C out. Okay, if I'm telling you how I made that command C out, okay, I am giving you into details the information, because if I'm telling you how the C out came about, definitely you know how it functions, as in terms of coming to print out something into details. So abstraction one way or the other is under encapsulation, because encapsulation is total like denial to real information about how something is built. You understand? So how the C out command was built, you don't know. Do you? Okay, if I have created my command C out and I tell you how I built that command, okay, then I have revealed everything about C out to you. In other words, I have unencapsulated it. Do you understand? But encapsulation is, you don't know how it was built. You don't know how it even came into existence. All we know is that per abstraction, all we know is that it shows out something on the console. Even with the abstraction, the basic function of how it works is what has been given to you. But to how it goes here in the system before it goes here, before it finally runs this part of the code, then finally this thing shows on your console, you don't know. That is what abstraction. But encapsulation is the real command itself, see out how it came to existence, you don't know, and I'm not sure it will ever be made known to you. Please, do you understand?
Yes.
That's why I came in with the example of the Coca-Cola, that the ingredients to make the Coke, they're the amount. But which ingredients came into the bottle first, into this one second, what temperature was applied, how the stirring was done, how it was left over for some days, all those things has been kept away from. That is what I mean by encapsulation. Please, has the understanding been achieved now?
Yes.
Okay, I'm glad then. All right. And I think the understanding has been achieved for everybody too. Everybody. A reaction. Okay. Silence. Response. So okay, Joshua has reacted. So let's go on. Please, if you don't understand, say it too. Okay, so inheritance. And last time I was trying to explain what inheritance is. Okay, if I say you inherit something, one way or the other, it's that you work for it or it was given to you. So I'm
Hello,
saying
sir.
that there's somebody speaking. Okay, Richard. Sorry, I
Yeah.
didn't see your hand up. Richard, hello.
Hello, sir. Can
Richard,
you
if you
hear
are,
me?
yeah, yeah, I can hear you now. Hello.
Yes, sir.
Yeah, I can hear you now.
Okay,
Okay,
so with
Richard, I
the
don't know.
encapsulation, can you also see that it hides internal details?
Yes, it hides internal details, and it is true. It's 100% true. It hides the internal details because, and I like the fact I use the word details. Okay, because when
Yeah,
I'm
please,
giving you
can you hear
details,
me?
I'm giving. Yeah, I can hear you. I can hear. And I hope you can also hear me. You are right. You are right with what you said. It hides internal details. Okay. The details to how something came into existence is encapsulated. And if that information is revealed to you, you can make that same item or even make one better than it. Are you okay? So because of that, these details have been what? Encapsulated. Do you understand? The details to how a command came into existence has been encapsulated. The details to how I always try to use the Coca-Cola. I don't know why I'm using Coca-Cola, but how Coca-Cola came, how the ingredients were placed together to form that Coca-Cola has been encapsulated. The ingredients that they are giving it to you, but the order in which they came in into the preparation, what temperature, how it was boiled, how long this chemical was boiled, their quantity and all has been kept away from you. Do you understand? That is what you mean by encapsulation. So the details, you are right. Do you understand?
Okay, thank you. Thank
Okay, let's continue then. So we are talking about inheritance, and I'm saying that we have superclass and what a subclass. Okay, so I was trying to tell you what a class with using practical life, saying that it is like a recipe to prepare food, okay, or something. Okay, out of what comes out of that recipe we followed is the object. Okay, so if I say I'm following a recipe to prepare, maybe let's make a simple food like garisokis. Okay. So at the end of the day, the garisokis I made becomes the object, but the recipe I follow to make that garisokis the class. Are you okay? Good. Now, inside the making of garisokis, I give certain things like commands like stir it, pour water, the verbs. Okay, that becomes methods. Are you okay? So let's get these three terms very clearly. Class, recipe, okay, object, what comes out of the recipe, and then the methods are the word method, right? It explains itself, like how something is done. Okay, so which one you put, so put this one in this, stir this one, those are the methods. Are you okay? So when I say I'm following I'm in a particular class, okay, let's say that class is a super class. That is the general class or the class or the main class where other classes inherit from. That's what we call it, the super class. And the one doing the inheriting is the subclass. It's like folders. If you know what a folder is, you know that when I create a folder and I put it in another folder, okay, the main folder that is keeping the other folder is the parent folder. And then the other folder I place inside is called the subfolder. Okay. And it is inheriting some, if it has no business with the main folder or the parent. Imagine if I create a folder and I name it exam questions. Okay, then you open the folder, then you see movies inside, or a folder that says movies, a subfolder that says movies. Like for some reason, it has nothing to in relation. Are you okay? But if I say exam questions as the super folder, let's take that super class as super folder. That's the parent folder. Then when you open that folder, you see other folders. And those other folders, maybe I've named it first term, second term, third term. Are you following? Then I open first term, then I see 2025, 2026. Are you okay? So this will tell you that these are exam questions for first term, 2025 and 2026. You understand? Where the exam questions folder becomes the super class, okay? 2025, what do you call it? First term becomes the what? The subclass. And 2025, 2026 become also a subclass of that subclass that came before it. You understand? So to it, to the 2025, 2026, okay, these two folders become, I wish I can write on the screen to explain. Oh, will somebody help me with writing? I don't normally use PowerPoint, so if there's a tool for writing here, I'm not seeing it. Somebody help me. Anybody with PowerPoint experience, do we write on anything? Just help me. I don't use PowerPoint at all. I don't use it at all. So I have no idea which tool I'm going to use to write on the screen. If there is a possibility, let me know. If not, to let's continue like that, Joe. What I'm trying to say is that okay, let me just find another interface to write. Let me just open Microsoft Word. Show that please I can use a little bit of writing. Oh, just give it a moment. Okay, let me press a Control N. Okay, Control N. Okay, and Control N is not Control N, so I don't know why it's opening this document. So Okay, let me open this one and create a new. Very good. Now, pencil, 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 draw, design, draw. Okay, there's a draw. Okay, so I have. Let's take this guy here. I am saying that. Okay, I am saying that. Imagine this guy here. Oh, this is a bad drawing. This guy here is a folder. Okay, and in this case, this is our parent folder. I'm going to indicate it by making it a bit dirty. So we know this is the main folder. Okay. Then under it, okay, under this folder, I created subfolders. Okay. Subfolders. Now, I hope you can all see my screen on what I'm doing here. Because maybe I'm make a sudden if you cannot see my screen, okay, very good, Joshua, thank you. I like your reactions. It's making the lesson nice. Okay, so subfolder. Now under this particular subfolder here, okay. Let me click on this thing again. I don't know why it's. Let me make this one's better. Okay, under this, view. Yes. Okay, under this subfolder here. I don't know why when under this subfolder here. Let me use this guy. Pencil is here. Okay. Under this subfolder here, I have another folder and another folder. Okay, that is for this particular subfolder here. This one, not this one. No. Now let's try and use superclass and subclass and all those things to try and explain. I'm saying this is my superclass. This guy here is my superclass. Okay. All right. Down here we have a subclass, another subclass belonging to this superclass here. And inside this subclass, I have other subclasses. In this case, this one becomes a superclass to these ones. I hope you are getting what I'm trying to say. This guy here becomes the superclass of these ones. Now, as I was saying, imagine if I say you are preparing Garriso cookies, okay? The recipe for preparing Garriso cookies. At the end of the day, what comes out is Garriso cookies. So I pour sugar inside, I pour something here. Now I can prepare another food and use some of these ingredients, but it will bring out another food. That's what I mean by a subclass. Okay, so maybe I'm preparing. What am I preparing? That I'll be needing sugar and water. Maybe we are preparing some tea. Let me put some tea there. Okay, probably you put in some sugar, maybe water as well. Even not sugar, let's look at water. Okay, water went inside for Gary. Water is also now going inside for the tea. So understand that the Gary preparation, the recipe for Gary, okay, is here. When something else inherits even just one of the ingredients, then it becomes a what? A subclass of the superclass. You understand? This is the superclass, the recipe. We are following it to prepare Gary. But when we're preparing tea, something also inherited something from that recipe, and that is water. Do you understand? So therefore, there's no need for me to come and type water here and come and type water. I can just refer to that particular and as an inheritance. So it will just go and inherit the water from the superclass. Please, are you getting what I'm trying to say? If so, like a thumbs up or something. If not, then I have to take it again. Okay, so the whole concept of folders, subfolders, and all that's like the exact same thing. Okay, I can't be a subfolder belonging to a parent folder if I have no relation. Like I've created a folder like back in those times. My teacher used to create this joke of pornography. It's like you open one folder, you see folder A, folder B, folder C. By the time you get to the real videos, folders best 1,000 and AJ. You understand? You will even give up along the way because you've opened folder A, inside folder A, I see folder AB, AC, AD. Like they come and open, you don't know which one is the thing is inside. So you're not come to give a random guess. So let's take you went for A B first. Then when you went to the A B, you see A B C, A B D, A B E, like all this was so like before you get to the real content, actually, then you have to be a pro because the folders you open, the subfolders you open before you get there. Are you okay? So it's like that kind of concept. Okay, so we are not trying to make our code plenty. We are just trying to pick from a code that has already been written or pick from a recipe that is already existing because what we are trying to prepare right now, some of the ingredients are also found in that recipe. Do you understand what I'm trying to say? So I just go and pick from there and come. I don't have to rewrite everything all over again. That's what I mean by inheritance. Okay, and I think the understanding has been cut across as well. Let me save this guy. That's my exam questions. Then let me go back to my PowerPoint presentation. Okay, so let's continue. Okay, going down, I think I explained this thing the last time. We don't need to waste time on this. Time is already far gone. Okay, so vehicle, motorcycle, car, truck, sediment. Okay, so even though all these things are vehicles here, it's not every one of them that is a car. You understand? So if I create a super class called vehicle. Okay, inside this superclass are subclasses. Okay, we have motorcycle, cars, and trucks. These are all vehicles. Are you okay? But when I come to cars and subclass, there's also what another group of what things that are existing as a car. That is one example is down Toyota and the rest. Do you understand? Understand the fact that because these guys are inheriting from this guy, okay, this sedan and SUV is inheriting from cars. This guy, even though it is a subclass of the main class or the super class, these ones are also subclasses of this guy. So this one becomes the super class for these two pictures we are seeing here. Please, are you getting the concept? Joshua, please, you will be done aside. No, what prompting me why now. Okay, so that is that. Let's continue. Today my main topic I'm in course here. Because I have a feeling say the mechanic last time no way. Now they have a fact. Okay, now poly, polymorphism. Yeah, I say no. Now polymorphism refers to the creation of items, okay, that have similar behavior. Let me put it in other words so that a basic understanding can be achieved. Okay. When I say polymorphism, and I made some simple notes here to refer to. Okay, these are the types of polymorphism I said. Okay, the essence of creating notes if you can't find the notes. I can't find the note. Let me go up a little. Oh, oh no. Okay, polymorphism. Okay, this means one name, many actions. I'll explain. And this is the saying that from what we are having here, they say, for example, objects may override common parent. This one, you know, we understand. Let me just take the polymorphism from beginning. Okay, so that let me see types of polymorphism, many forms. Okay, polymorphism. Okay, now in programming, okay, polymorphism means that the same action can work with different ways depending on the object. Now, let me tell you this. If I say open to all of us, let's answer this question. Okay, because actions are methods. Actions, I told you that methods talks about the actions. So right now, if I tell you that say open to a door, what will you be expecting? When I say open to a door, what will you be expecting? This is like a method or an action you are calling out. Polymorphism. If I tell you to say open to a door, like open, door open, what will you be expecting? Anybody can unmute and speak. Hey, hey, nobody is speaking. Wow. if this one happens, then it kills my spirit too. Like I'm telling you the truth. If I'm teaching and like, cause guys, anyway, let's continue. So, oh yeah. The laughing emojis can come in though, but I'm being frank. Okay, a class is a class when like it's interactive. If I'm saying something, you're not giving feedback. At the end of the day, how am I supposed to also know that what I'm teaching is getting somewhere? Because I can't just come and sit behind my computer and be talking to my laptop. You understand? At least I also get some feedback from the people I'm teaching. So if say open to a door, what will you be expecting? And I'm expecting like some kind of response. You understand? It also helps me know that what I'm teaching I'm following. If I'm just talking. Somebody can even doze off. But the fact that I'm interacting with you guys keeps you awake. So if I say open to a door, what will you be expecting that the door will do? That's what I'm asking.
Nothing. Anna. I guess the
It's
door will do
what?
nothing. You tell a door
I
to
can't hear.
open, it
Please
will do
can you be a
nothing.
little
Yeah, can you hear me?
very good. So we are expecting that the door will swing from its initial position of being closed to opening, giving space, right? But if you use that same word open to a file, what are you expecting the file to do? This is the same word open. I've not changed the word. The same method, the same action, just that I'm giving it to different objects in a class. So therefore, the outcome is going to be different. If I say file open, the file will open and show me its content. That same word open, if I give it to a browser, it will open a web page. Do you follow? So the action can remain the same, but the object in which it is referring to may bring out a different outcome. That is what we mean by polymorphism. And what I said is that one name, many actions. Do you understand? So I can say, I can give the same command to something, but it will work differently depending on one, the situation, and two, the object in which I'm referring to. I'm just trying to be a little bit naughty here. Let me be a little bit. Am I allowed to be a little bit naughty here?
Of course.
Yes, I'm allowed. Right, of course. Let me be a little bit naughty. We are all adults here. If I Joshua, I don't hear me. If I tell uh, you to come, what will you do? You walk towards me, right? Obviously. But imagine if you are doing mama and dada, okay, and I tell you to come. Sorry, oh. And I tell you to come, okay? At that point in time, it's not working towards me that I'm talking about. You
Hey,
understand what I'm trying to say? And I asked permission to be naughty. Prince, don't bring yourself, please. I beg you. That's why I asked the permission. Okay, I'm just trying to put up an understanding here. Okay, the same action, but the situation caused a different response. The same action, but the object in which you are referring to caused a different response. That is what we mean by polymorphism. I don't really have to talk plenty about it. Just take this basic understanding that the same action. Because if I'm talking to you as my party, let me just say chairman Jimina, you might take it on the on the low, but try that same thing with lecturer. How does it? Lecturer Jimino, hey, F sɛ biribi wɔ F na akyi a no na abɛnya. Sɛ biribi wɔ ase akyi a Kennedy bɛma nyame a wode biribi wɔ F na akyi a if there was an F10 ebi a no na wobɛnya. Ka kyerɛ lecturer sɛ wɔngya agye mi no. Kwaku. You explain tire. You understand? So the bottom line is that, okay, you have to know the situation you are inside to call out a particular what method or action to the object. Okay, so if I'm telling the object to come, I'll not go there again. Sorry, let me use a different thing. Okay, and then people start to see you some way, but I'm just trying to state as a teacher, you have to find different way. That's why I said we are all adults here. Okay,
we
we are
see
not,
you
no,
long
there's no
time.
kid here. Oh, okay. So let's look at some everyday examples with polymorphism. Okay, think about the word move. Okay, move. If I tell a car to move, who can guess what the outcome will be? I'm referring to the object car, and I'm using the method or action move. What will the car do? Okay, Prince, you can speak.
It will change position.
Very good. It will change its position on land. Okay, on land. But if I tell a boat to move, what am I doing? Because that we are looking at the situation as well. Apart from referring to a different object, we're also looking at the situation the object finds itself. So, Prince, you can speak for that one too. If I tell a boat to move, what will it do?
This time I think position change on water, right?
Very good. So therefore, I've also tackled the aspect of situation. Okay, even though both of them are performing the action of changing positions, okay, the situation changed. The situation changed the outcome. One is on land and one is on water. Please do you understand? Prince, you're muted. I thought you were about to say something. Okay, Vida, thank you for that reaction. Let's look at something in programming. So if I tell an object, okay, circle, like an object circle to draw, okay, what is the outcome going to be? A substance with a circumference, right? These are all shapes. Don't forget though. Square, what is going to be the outcome? If I tell a square to draw, an object square to draw, definitely the square is going to follow its attributes and bring out a box with equal what size, but they all receive the action draw. But to which object I'm referring to, the outcome was different. That's what I'm talking about as polymorphism. Are you okay? And that is it. Okay, who has any question to ask about that thing? This is the first time I've seen a big word I've been able to answer it to. Why that? Like most of the time, one by I mean to me, word, but I said then they might try polymorphism there. I said that form. To me, I'm a my idea. Okay, so let's look at uh, some types of polymorphism. Okay, let's look at some types of polymorphism. And the lecturer said that we have the method overriding, okay, and method overloading. Let's understand these two real quick. And even if I'm able to put that these two understandings into your head and we are okay, I think I can relax now. Okay, because these are the two ones that child one here to confuse you. Now, what do you mean by method overriding? Now let's think of like a general rule, okay, in a parent class. And I told you what a class is. Okay. When I say, okay, a child in that parent class, or maybe say a child or an object in that class, okay, can replace the rule within that class. Okay, there are some rules set by the class, but the child can replace the rule in. That's what we mean by override. When we say override something, okay, you treat it like as if it did not exist. Okay, the rule did not exist. You have over past tense is what? Right about why? Is over what? Is it overridden?
Override.
Okay. The by that kind, So let's take for instance an animal. Okay, I've created a parent class animal. Okay, then I put inside that parent class the object dog. Okay, then I give the dog a command. Pay attention. I give the dog an action or a method saying make a sound. What do you think the dog will do? It will bark. I understand the fact that the dog will bark. Then I tell a cat, which is also an animal in that class, because I said animals, to also make a sound. What do you think the cat will do? It will meow. If I Ish, obi besrɛ me. Sɛ ba. Okay. So we are saying that the same method make a sound was used, but each object inside that class brought out a different result. Are you okay? Over they made their own sound. Let me put it that way, based on what object I was referring to. That is what I mean by method overriding. Are you okay? So in a class animal, or animals, okay, I told each particular animal inside the class to make a sound. The outcomes were different because at the end of the day, what I say make a sound. So I'm expecting a sound to come out. A sound, but probably in the class the rule was one particular sound should come out, like one particular consistent sound should come out, but that was overridden, bringing out different sound because of the different objects that were existing in the class. Even if I should put dog, animal, cat, animals like dog, cat, maybe another animal down, then I'm teaching them a song that they should sing, okay, and I give them a rhythm. Listen to this. I give them the rhythm of the song because I know they can't pronounce the words. So then maybe they are going to make sound to follow the rhythm of the song. Okay, at the end of the day, my rhythm I give as the parents class teaching them the song. They are not going to make the exact same sound because the sounds they make are different. They have overridden my original sound based on the sound that a dog is supposed to make. So if I say they should sing maybe if you're happy and clap your hands. Okay, like I give them the rhythm. Pa, 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 pa. The dog will say, whoa, 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 whoa. Why am I behaving like a child? The cat will say, meow, 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 meow. Okay, I gave a parent sound, okay, a parent rule, a rhythm, and I was expecting that same sound to come out, but it was overridden based on the objects out, even though it was, I don't know if I say the same rhythm, but the sound was not sounding the same because of the object I was referring to. That is method over what? Overriding. Now, method overloading, which are the two types of polymorphisms that I said they are there. Okay. Now the same name but different inputs. Okay. So if I say, for instance, add, I'm adding certain numbers together. The command is add, 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 add. Okay. Now listen. When I say add, and I put into the maybe the brackets for the add, and I put two numbers there. Okay, I've given the instruction to the system to add two numbers. The end result of this whole thing is that it's going to put, even though adding is being done, two numbers are going to be added because inside the parentheses, or what we call as the arguments, okay, I place only two numbers. I create another add, but I place in three numbers. What is going to be done? The same adding is going to be done, but three numbers are going to what? To carry that, they are going to carry out that action of adding. Okay, so what we mean by method overriding is the same method add, but if it works differently, is dependent on how many values I gave that action. If I say prepare rice and stew, and then I gave you 1 cup of rice, okay, at the end of the day, you prepare rice and stew, okay, but the quantity of rice that will come out will depend on the quantity of that's the cup of rice I gave you. At the end of the day, you have prepared rice. The action was prepare rice. Please do you understand? That is method over what? Overloading. Okay, and that is the same what do we call it? The same command, but the inputs that you are providing for that command to be executed, okay, are not the same. So therefore, obviously, the outcome will also differ, but the same action was carried out by each and every one of them. So if I say add and I provided two numbers for the addition to, okay, yes, the outcome is going to be different because two numbers is what I provided. Are you okay? But the same action of adding is going to be done. But remember, with the overriding, okay, they override my command based on what object I'm referring to. Get a difference. If I refer to a dog to make a sound, it's going to bark. If I refer to a cat to make a sound, it's going to meow. These two outcomes are sound, but they are different sounds. It's over. I won't try it. They laugh at me. It's over the past tense of riding. Okay, the what do you call it, but with the command I am giving as add, the adding is going to be done by everything, by every entity, but the values I gave it was what is going to cause the outcome to be different. I hope you understand. No talking, so it means it's understood. Okay.
Yes, please. Well understood.
Okay, so that means I can go. Okay, let me go on. PowerPoint. Let's go. So polymorphism. I think I've explained what an object is. Okay, what is an object? An object is an entity which has a state and a defined set of operations which operates on that state. So first of all, the recipe, as I said, is the class. What came out is the what? The food, the object. Are you okay? And we are saying that this object um has a state, okay, because the food that came out, if I'm supposed to prepare rice, then at the end of the day that's plain rice, okay, at the end of the day it comes out watery, and so like I so definitely you will not call it plain rice that we eat with stew, we call it rice water. You understand? You definitely call it what? Rice water. So the state of the object is also part. Are you okay? Even though it followed the recipe, the state of it matters. Okay. At the end of the day, what came out is what I said. As I said, the recipe is there, dear. But we are the end result determines the object. Okay. So we say that an object is an entity which has a state and a defined set of operations which operates on that state. So the defined set of operations is what you did using the recipe, okay, so that at the end of the day, instead of acquiring plain rice, we ended up with rice water. Are you okay? And you can tell that definitely you added, that's what we say is defined. You added more water than necessary. Please, do you understand? So that's what an object is. So the state is represented as a set of object attributes. That's why I said, how if you look at it, it's watery. So you can't call it an attribute. The attribute for the rice we are seeing there is that it's watery. So you can't call it plain rice, edible, compatible with stew. But since so they all the still good, so they are be person jollof, they are fine. But on person be jollof now, person with the rice and still need what is in front of you is rice water. You understand? Looking at a state gives look in the state now, you see say it has some attributes. Do you understand? That is being watery. Okay. So based on its defined state and attributes, we can now classify the objects under a particular class as rice water, even though it was supposed to be under plain rice. I hope like objects are like are also understood.
Yes, please.
Okay, let's continue. So the time is far gone, so we will not objects are created according to some object class definitions. So objects are related to class. Don't forget that because out of a class comes a particular object. Okay, and inside the object, inside that you have to tell what the object what they are supposed to be doing. Are you okay? So therefore, we are going to use something called methods. When you hear methods, they are like a set of instructions directed towards objects in a particular class. So take note of that as well. Okay. Okay, so object is an instance into parentheses member of a class. Okay, so yeah, as I said, objects map onto classes. Okay, now the beauty is we can create multiple instances of the same object to do the same kind of work with different circumstances, and that is known as variable settings. You know what a variable is? Variable is a letter probably representing let me say a letter representing a number that can a number that can be assumed in any way. So if I say let like for instance, they say find x. In the process of finding x, you don't know what x is. So once you are solving, x can be any number. So therefore, x becomes a variable. We understand. You can assume any number or any form. That's what I mean. And it varies. So it can assume any form. It's not constant. So therefore, we call it a variable. So variable settings is trying to say that these objects, okay, can assume any outcome or can do anything based on the circumstances you create for them. Do you understand what I'm trying to say? That's what I'm saying. If I give a command to a door to open, that same command to a file to open. Look at, we are talking about different objects over here. Are you okay? We are talking about different objects over here, and then the circumstances are all the same. Okay, when I'm saying circumstances, I mean by like the command I'm giving to them, they are all the same. Okay, even though the objects are different. Okay, as I said, we'll come back to different circumstances. I stated an example of different circumstances earlier, if you remember, where the circumstances were different, the object was the same. So therefore, the outcome became what? Different, and that's what I mean by variable settings. Are you okay? So the instance will keep track of its own state of variable independence of other instances of the same class. I wish I could this. How can I explain this in a more basic form? God help give me the words so I can explain this in a basic. Sometimes what I see, but I still it's a problem. So the instance, let's take it. First of all, let's go back to understanding what an instance is. Okay, is an object is an instance, okay, which they further give information about saying a member. So we can see that the member will keep track of its own stake of variables independent of other instances of the same class. What is trying to say that and the object, okay, or the member of that class, okay, will keep track of its changes that it undergoes, but these changes that will not be dependent on other instances or other objects in that same class. It will be independent. Are you okay? So if at this point s is a string and it followed a particular command, and at the end of the day its outcome became an integer, okay, or a boolean, or even a float, okay, as is undergoing these changes, it has no effect on other instances in that same class. It's independent. That's what I'm just trying to say. Okay, is that clear? I'm trying to explain it, but I hope it is clear. Is that clear? No reaction. Actually, this thing is worry. Anyway, okay. So at this room, I say, well, how do I even put this? Okay, so let's just say I want to give chances for some questions to be asked, if there are any. Okay, before I proceed, if you have any question at any point I was presenting and you want to ask, okay, Prince has unmuted the mic. Okay, Prince, you have a question you would like to ask us? Ask me, sorry. So I address it for you. Like the way you guys don't talk, it's like as if like I'm the best teacher, like I'm teaching Biama. Like I
was
teach.
me, Prince.
You are too good.
Okay,
Hey,
all right.
hey, people they carry me, they go. Hey, they beg. I beg, ask questions. Why? Who bigger questions, you know? The questions also help me know that this is where you are facing challenge and all. Like, so we also address that. Okay. Yes, I know Zemo, like sometimes talking through the mic and all in some way, but ask a question if we that's why we are all here. So we are trying to say that throughout my whole presentation, apart from the at certain points where some questions were asked, like everybody is okay now. Everybody. This is wonderful. Very wonderful. Okay, then. So do we all agree? We are going to do a quick voting by raising hands. Okay. If you are in agreement or in acceptance for us to move to use the rest of them, so you are not going to ask any question, to look at the IDs and how to set it up, raise your hand. If you are in acceptance of that, raise your hand. If you are not, you can keep your hands down anyway. Okay, I have one, two. Remember, majority carries the vote, but I have three. So we have how many, including myself. Okay, We are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people here, and then I have 3 in acceptance of the motion. Oh, 4 now. That's still is minority. So should we say that those that are not raising your hand, you help the 4 set up their environment? That's the conclusion. So please, those that have raised your hand, you can see Monica hands is down, Jedediah hands is down. Hey, okay, the hands are raising. Hey, the hands are raising because somebody will contact you for you are raising hands. Hey, people, don't do that too. Okay, so I think at this point majority carries the vote. So let's first look at the jet brains and that environment and how to get the downloads of the full version that he was talking about and all, so that you will not struggle probably if he jumps into the ID environment or the coding environment. Nevertheless, you can also use virtual studio code to program all these words 3 languages we are about to learn about. Okay, but there are some things you have to download called extensions. Okay, and if we are interested in the Visual Studio Code, when we get another chance, I'll look at that one for you. But for now, we are going to do what the lecturer said. Okay. So since you cannot see my screen, let's quickly jump to, I don't know which one of the browsers I should use. Let me use Brave since it's faster than. Okay, so I do a lot of PDF to word conversion, so don't mind me. Okay, so we are going to look at JetBrains. Okay, JetBrains. You can type that in your browser. Okay, it will take you here. This is the first thing you are going to see is JetBrains essentials tools for software developers and teams. So you click on that. If you are following, please do that. Okay, please do that for me. So you click on that, then their web page will open for you to have this interface. Okay. Um Joshua, please prompt me when anybody has a question to ask. So for now, we can all lower our hands so that Joshua will be able to
Okay, sir.
identify. Vida, please, you can work alongside Joshua. So maybe he too might be tighter somewhere. Okay, so Vida, please also help me out. Okay. In fact, let's all help ourselves
All
out.
right, sure.
Monica,
Okay.
Abuaje Praise, Joel, please. Well, look, at this point, it's a good discussion. Wow, say what question beside or mute and talk because I can't be here. I can't be watching this one. So just unmute and then let us know. I will okay talk freely. So the whole pro version and all. Okay, we are going to this particular part. Okay, and it says education. I'm sure you can all see education. So when I click on education, okay, I'm going to see a section that says free licenses. Okay, free licenses. Under it, I'm going to click on students because we are not the teachers. Okay, good. Now we are going to come here and click on this button, request now, request now, request now. So I'll click on request now. Okay, then it will load. I have already done my everything, so there are certain things I will just jump. Okay, but you should follow suit. So you are going to fill this questionnaire. They say status. I am a student. You take the I'm a student one, not I'm a teacher. Region Ghana. I think I've already done all these things, so you can see it from here. Level of study you choose undergraduate. Okay, then is computer science or engineering your major field to study? You say yes. If you are saying no, then I wonder what you are doing over there. Okay, so yes, obviously. Then you provide your email. Bear in mind, it's supposed to be your student email, say university email address. So don't enter your personal email and tell me it did not work. That's why it's a request. You are sending to them. They'll check through the email. They'll check the university. Remember, the university is a very big university. It's known outside and all. So that's why people travel from other countries here. So your email let me say nature is known for the type of university you are attending. So if you type it here, the system will check and say, okay, This is the email. Is it true? Is it particularly a student over there? Does he learn this course? Then it will verify that. Then you put your personal email here. Don't interchange these two. I repeat, don't interchange these two. Okay, so make sure you are putting the right details at the right place. Let me bring it to our lesson. It's like as if you are with the interest. So let's continue. So we have name here. You enter your first name here. Then you enter your last name here. Then I'm not sure you take I am under 13 years old, or otherwise what are you doing in university in the first place? Unless for some reason we are promoted from basic 1 to basic what? Probably somebody should do the calculation, let us know what you be doing in university at the age of 13. Okay, then you also take this part and said, I have read, which normally we don't read. I've never done that before in my life, but I always accept it. Okay, so you read this part, Joshua, you're laughing. Oh, but it is true. Imagine if you are doing Windows installation and you get to a part where you have to accept the terms. Look, it's like a whole slide, the whole lectures. Man, kind of now. Just because I want to accept to use your products. Okay, so then also I would like to receive information about JetBrains Academy, blah blah blah. You can choose, this one's optional. You can choose to take it or not. Okay. Then you come to apply for free what products. You click on this. A link will be sent to you. You click on that link and follow suit. Okay, so when you click on that link, it will bring you to something like this. Let me go back so that you see what I'm talking about. It will bring you to something like this interface, okay, where you are going to choose the programming language. You go down, like down. Keep going down until you see this thing. It says explore and find the right JetBrains team tool. So you click on this one. When you click on it, this is what you are going to see. Are you seeing what I'm seeing? If you are seeing what I'm seeing, there we go. So this is when you know the language you are going to, but if you don't know, you come to this section. Okay, then you select the language, which in this case, we are going to learn C. So it gives you one that you can download for C. Okay, you can uncheck it. You can also add Java. It gives you one that you should download for Java and so on. But I don't really like this place. Okay, I like the what do you call it, products. This guy here. And then you come to all IDEs. Okay, that's when you see the one that the lecturer was talking about. Okay, you see. So here's where you choose your language. You see, this interface is much better. Okay,
Hello.
so I'll take it again. Yes, please.
Please, can you go back? My network.
Okay, so I said when the link is sent to you after filling the forms and all, it will take you to this same interface
So
we
I
came.
was at explore for your best team something last night.
Explore.
You scroll down to explore. That's where I got to.
Oh yeah. That's what I'm saying. That part you can ignore it because it will bring you to this interface. Okay, so you don't need to go that far. You can just click on products up here. Are you okay?
Okay.
When you click on products, okay, then you come to all IDEs. It's under JetBrains IDEs. Do you see it here? Then you click on this one. Okay, when you click on it, it will bring you to this interface where you scroll down and choose the language you want from this section. Okay, so immediately you tap on the language, the IDE should be provided. So this time around, we are downloading Rider for C. I said Rider for C. Take note of that. Rider for C. Then we are for Java, when you click on it, we are download. It's only one that will appear, and that is the Intelli idea. Intelli, whatever. But it has idea in caps as part of its name. When you come and click on it, this is the only one that will appear. Then for Python, where is Python? Python, you also have two, but they are downloading PyCharm. You are downloading what? PyCharm. Okay. So when you download all these things, they are very huge. They're not very huge inside, but they are relatively huge. Okay, I think the least one is about 800 and something megabytes, but the rest is a gig point something. So I think a midnight bundle will save you the hassle. You download them, then we will talk about installations. when we meet. Actually, it's just like installing something, any application on your computer. So you go through the whole installation process. But my problem is this: the thing we did for C++. If you remember, you come to this place and type edit. If you remember, edit environment variable, also edit environment variables. Okay, so that's where you come to. But before you come here, you make sure you open this. After installation, the files are going to be in program files. So you come to your local drive C. You come to program files. Okay. Then you see they are here. Mine is this is JetBrains. Okay, this is JetBrains. Let me see if I see it. Okay, so I think everything is here. JetBrains. Okay, JetBrains. You click on JetBrains. Okay, that's where you're going to see your rider and your Pi charm and then your Intelli idea. Okay, then you click on rider. You can choose any of them in the order in which you want. Then you click on this. Then you click on this one. Then you click on this one. Unnecessary. Lot of we. I'm not caring. Supposed to be beans. There's supposed to be a bean somewhere. Let me see if I go back. I find it. There's supposed to be a bean somewhere. Let me come in and see. Okay, here's it. So for the Intelli idea, okay, you see a bin. Just double click on the bin to open it. Then copy the file path. How do we copy file path? It is up here. Just click up here. It highlights it like this. Then you press Ctrl+C. Then you come to your edit environment variable. Did I close that window? So I closed it. Let me type it again. Edit environment variable. Remember, we have copied the file path to that. Okay, I have done that. So you come to this file, this path, okay, that says user variables for Akaza. Okay, that's the name of my user account. I've named it Akaza. But if you have named yours your name, you'll see your name here. Then you come and double click on path. Then you come to new. You create this, then you Control-V to paste the file path here. You can see I've done it for Intelli idea and rider. Are you okay? So you paste it here, then you just click on OK. Are you okay? It adds the path to your system file directory, whatever. So that whenever the computer needs to run some codes or fetch something from there, it can come to the path and find it. So you come down here to system variables and do the same thing. Double click on path. Double click on path. Why isn't this one working? Double click on path. They're not allowing me to double click, but it's supposed to work. Let me come to edit environment variables again. It's supposed to work. I can close Microsoft Word now. Let's see. Okay, so let's come to edit environment variable again. Variables. Let me see if I double click on it this time. Look, it worked the first time. I don't know why it's behaving like that, but I'm sure yours it will work. Click on it. It will open the same thing as it did for this one. You click on new, paste your file path, and click on OK. That is all. Okay, you do it for both up and down, and then for the programming language. But remember, it is the bin file that we are copying the file path. So you double click on bin. Then before you come and copy the file path, are you okay? So that is that. I don't think at this point anybody has a question to ask. So that is almost. You don't need any compiler. Emmanuel, you can ask your question. Okay, it's down. That means that you guys are okay. So you follow this procedure. If not, I can see if I had to download because when I saw the sizes were huge. I have no other choice but to download it and install them. But yes, I can downloading. But I don't think we can all sit here and wait for something 1 gig in size, 1 point something gig to finish download. So in your own personal time, just download them. Then maybe you can DM me when you take screenshots, then send it to me that this is what I've got into. Then what should I do? What should I do? as I said, I'll be here to assist you. Okay, I'm here for you. I did for you. Okay, so I think at this point we can end our lectures. We can end our lecture, right? Unless anybody has anything to say.
Thank you so much.
Okay, so thank you to Vida for having me. Thank you all for having me. Okay, and have a
God
wonderful
bless you.
rest of the evening. Okay, bye.
Bye.